Hello, American sheep industry. Honored to be here from afar. I wish I could join you in person. It's actually a Sunday night. I'm just getting a little time from work to take a break and share with you some information that Rita and I and Ryan Mahoney discussed prior to you all convening. I'm going to give a short presentation on the work of my organization and all the collaborators that make this work a reality. So we're going to talk about soil health, and we're going to talk about carbon sequestration and how it positively can affect the price that you receive for your wool and the markets that can open when we consider soil health and climate in our work. So I don't have much time, so I'm going to get right to the point. So we start with the premise of which carbon pool provides your clothing. This is a question that I've asked for some time because I am a vocationally trained weaver, a natural dyer. I went to UC Davis and studied agriculture. I've always been thinking about the nexus between the clothes that we wear and the pool of carbon that they come from, which essentially is, is it from the biosphere? Is it from a product of agriculture? Is it from the lithosphere? Is it a product of fossil fuel extraction? Are we paying attention to the effects of our choices and how we impart management decisions on these different carbon pools? These are all questions. So the first question that I think divides polyester, nylon, capilene, and acrylic from wool, cotton, rami, flax, hemp is which carbon pool it comes from. So just prior to us having any conversations around what's a better fiber for our future, I think we have to start with this question, because it's true that the extraction of fossil fuels is required for acrylic, polyester, and nylon. So when someone comes and tells you that wool isn't sustainable or that there's something inherently wrong with the domestication of animals, I would contort that there's actually a lot wrong with the fact that we're extracting fossil fuels from most of our clothing. 70% by volume for the world's textiles are sourced from fracked gas or coal tar extraction, and the synthetic dyes as well. So for our region, I'm in North Central California. I work in 51 counties, and I've been thinking a lot about becoming more resilient to climate change. I've been thinking a lot about the future of agriculture and its economic viability and supporting those on the ground. And I've been looking for that nexus point between textiles revaluing a new textile culture that's coming from our farms and ranches, domestically produced, but also hits that hot button of trying to enhance carbon capture on these working lands so that we can tell a more positive, realistic, and practical story about the role of agriculture in the climate situation. So we've been looking regionally at farms and ranches that produce wool in particular, and looking at the potential for those landscapes to capture atmospheric carbon, even beyond business as usual. Your land is always capturing carbon. That's what photosynthesis is. That's what grass is doing. Here we are. Through the energy of the sun, the photon energy, your land is consistently where you graze, or if it's leased land, doesn't matter. The energy of the sun is igniting the plant material that your sheep are grazing. It's igniting that plant material to take up carbon dioxide from the atmosphere through the stoma. The energy of the sun is also there to break the molecule of CO2. That energy breaks it. It releases the oxygen that we breathe, and the carbon is then moved through the plant. And what they call the liquid carbon pathway, the plant transforms that atmospheric carbon into sugars that are released through the roots, and those roots then feed microbial and fungal networks. That's what we call the liquid carbon pathway. The plant also makes its own physical body out of carbon. And so when the plant goes into death or it's grazed, that carbon becomes embodied into the sheep's wool, or it becomes embodied in part of the soil as the microbes and earthworms take that carbon that's once atmospheric, now plant material, and they decompose it. So we call it the decomposition pathway, which earthworms do very well, but also ungulates when they graze grass, and then they create manure and bioavailable nutrients. That's what grazing is. It's like sequestering that carbon at the moment of grazing, turning that carbon into wool, turning a carbohydrate into a protein, and then the manure nutrifies that soil and then allows those plants to regrow even stronger every year. This does all happen with the art of agriculture, we call it. So all carbon in the carbohydrates comes from the air. A lot of people think that the carbon in plants comes from the soil. The carbon from plants comes from the air. So one way to define agriculture is the art of moving carbon between carbon pools, moving the carbon from the atmosphere to the biosphere to the soil. To do this, we are producing food, fuel, fiber, and flora. And the reason we're doing this work, we do know that, at least in my region, that the climate change impacts have resulted in more severe, tighter in succession drought cycles. So what maybe used to happen every 1,000 years or 12,000 or 1,200 years is now happening every 2 to 3 years. This effect of climate change has a lot to do with the amount of carbon that humans have released into the atmosphere through fossil fuel burning, and also through the way we've handled the management of our soil. About 45% to 50% of the carbon in our California soils has been released through tillage, through the annualization of the grasslands when the perennial grasses were overgrazed during Spanish colonization. The annual grasses, the European oat, for instance, and so many of the annual grasses, a lot of them are of European origin. They took over the grasslands, and that perennial grassland is in very short percentage of our total rangeland systems. There's very few intact perennial grasslands left. Those annual grasslands, they oxidize more carbon than the perennials. So this slide is basically to say, like, there is an issue, there is a problem. Agriculture is part of the solution, as are there other solutions like renewable energy and changing some aspects of the industrial economy and how we power it. But agriculture is a huge part of the solution, and we need to think about ourselves as part of the solution. So many of the practices that you can get credit for now in many ways, because they have a carbon drawdown measurement framework, are these practices that I have listed here. These are practices that our organization, in collaboration with the National Resource Conservation Service, in collaboration with resource conservation districts, in collaboration with some land trusts, in collaboration with the extension agents, have been saying, you know, these are practices that many growers have been doing since the Dust Bowl. These are practices that also have something we can measure. If you do this practice on your land or land that you lease, we can measure the amount of carbon that will be drawn down in 5 years. We can project forward to the amount of carbon that will be drawn down in 20 years or 80 years. These are practices, again, that have consistently been used by agrarians in the Western US in particular to mitigate against erosion. But not only do they mitigate against erosion and soil loss, but they're catalysts in building soil. Every time we build soil, if we build an inch of topsoil and we say, oh, we've increased the soil organic matter by 1%, half of what is in soil organic matter is straight up atmospheric carbon. So it's actually measurable to know how much carbon that you're drawing down. from the atmosphere. So given that we can measure it, we can attribute the success of drawing it down to those who draw it down, which are ranchers and farmers. So that this is the practice sequence that we've outlined. On very large scale ranches, we don't do soil sampling. It's not an accurate measurement of how much carbon you have in your landscape to take a few samples. If you are on a very large landscape, we use computer models to help us with that. But generally on small farms, we soil sample. We agree with the grower how they're going to implement one of those practices you saw on the last slide. We initiate a carbon farm practice, and we allow that grower to then become part of a transitional verification program. When they're fully verified, it means they have a whole plan, not just one practice, but they're thinking about their land in terms of a suite of practices that they commit to implement over time. And so we have, through our organization, stated that if you commit to a practice every year and the practice is outlined on a plan and you do annual implementation, you are then set up for us to measure your positive impact. Thus, we can communicate your positive impact to the marketplace. And we do this for free. We do not charge the growers because we're working with all the public services like the NRCS, the RCDs, the extension agents, the Healthy Soils program through the California Department of Food and Ag. We can help move this work without any outstanding costs to the grower. And we help do the monitoring. So we just ask growers, can you send us a photo? Or even if growers are posting photos on Instagram, I'll often say, like, can I use that photo? Can we use that as verification? Thank you for documenting it. And we ask that the grower or the RCD that they're working with, I'm often working through the RCD, asking them what they've done on that land. You know, how did that go? How many acres? How many linear feet? And then we put it up on a database and we document it. And when we figure out how many linear feet you've done something like a pollinator corridor, or how many acres you have applied compost, or how many acres you have implemented cover cropping on, we run those numbers through something called the Comet Planner. This is an environmental systems model that we've been using in concert with Colorado State University. It's a dynamic environmental systems model. It takes many different influences into effect, and it's able to give us a figure to state how much carbon you are sequestering in these time increments, 5 years, 20 years, 80 years. So here's an example of a carbon farm plan at the very end. After we show the maps of the ranch and different practices that you want to do, we'll often take the practices that you want to do and the ones that actually have a drawdown metric, and we'll create a table. So here's a ranch in Santa Barbara, and these are the practices that they listed they were very interested in doing. The carbon farm plan is meant to be a laundry list of things you want to do and things you're willing to do because you're curious. So here's a list of what this Cachuma Ranch is doing. And you can see they have a 20-year sequestration rate and a sequestration rate when all of their hedgerows and riparian restoration are fully mature. And here's the annual sequestration rate. So 6,081 metric tons to 7,396 metric tons per year can be sequestered on this ranch beyond business as usual scenarios. And here's some of the practices you're probably very familiar with: cover cropping, mulching, grassed waterways, alley cropping, riparian corridor restorations, critical planting areas, which return native plants to areas that might have been eroded and could also maybe fence out animals temporarily just to let an area restore. All of those practices are fairly familiar to the resource conservation districts. So the way that our organization works is we work in partnership with RCDs to develop these plans and to work with growers. These are the areas where carbon farming is already taking place. There's some transitional areas too where we don't work with an RCD, we work with a partner organization. So that's highlighted in blue, and all the green areas is where we have a partner in the RCD. We have enough ranches now, thanks to the kind commitment of many California-based ranchers, who's part of our regional scale-up of carbon farming. We have enough ranchers to have a critical mass of wool. And so during COVID, when economic issues were occurring with uptake in the meat markets, the cruise ships were shut down, airplane flights were shut down. The sale of meat from many growers I heard was challenging. There was a lot of economic uncertainty and complexity and worry during COVID. So our community started to build a climate beneficial wool pool. So we had individual ranches, and I was helping each of those ranches tell their story, get that story out to brands. Well, this year, with the help of Imperial Yarn and Stacy Chavez, who owns the company, I helped her work on a financial model. She was able to get a great loan to be able to actually pre-purchase the wool and move the wool from all these various ranches through a supply chain to have that wool even more value added for brands to utilize. With her work and the work of the manufacturers domestically, we've taken this wool pool and we've been able to make the wool more accessible to small brands, medium scale brands. Oh, that's a beautiful little shelter belt that we started. That's at Bear Ranch in Modoc County. I'll tell you more about the climate beneficial wool pool in just a moment, but these are some of the practices that growers are doing now, from beaver analogs, critical planting areas, composting, redwood tree, those are windbreaks, ceanothus and redwood tree, shelter belts, cover cropping using no-till strategies, rangeland plantings, reseeding rangelands with native species. These are all part of what the growers in this climate beneficial wool pool are doing right now. And these are some of the products that the companies that are participating in purchasing the wool, they're purchasing it as yarn, or they're purchasing it as finished goods, thanks to Stacy's work. You see sweaters now, pants, gloves, hats. That's a little more typical, but to see the clothing in full garb, it's really beautiful to see 100% wool. So Amy Livestock, I think Ryan will be speaking after me. His wool is in this, I don't know if you can see my cursor. His wool makes up the sweater and pants in the photo that is the second to the right on the top of the woman holding the oak tree. That's his wool. You see the wool of Bear Ranch in the Mount Diablo blanket that Koyuchi has made. You see Lauren Poncha and Jim Jensen, who produce coarse wool. Their wool is in duvet inserts and mattress toppers. You see a combination of wool sources from different ranches in California in the Juliana sweater to the far right. And you see some of Imperial Yarn's product making undyed yarn so that the natural dyer community can access climate beneficial wool as a yarn that they can then dye and sell. Fingerless gloves, children's hats. This is all product that's come out of the wool pool. The North Face also utilized the climate beneficial metrics to sell hats. You see this, warm your dome, not the globe. That's a Bear Ranch fiber shed / North Face / NRCS, Point Blue, Conservation Sciences collaboration. Here's more ways in which you see climate beneficial being marketed with product. This is a really beautiful knitting yarn. They used Bear Ranch as their first ranch in a series of ranches that they were giving transparency to, and they used climate beneficial as their beacon to sell the product. Then you see wool sponges being made out of the coarser wools, and some of the coarser wools then are also going into these pillows and mattress toppers. And for the brands, what FiberShed does is we do the mathematics to describe how the COMET modeling that I showed you earlier and the table that I showed you for Kachuma Ranch, we measure that against some generalized data on wool production, And we can show the brands that if these ranches and farms continue to implement their practices and achieve the goal of getting through their laundry list, we have not seen one ranch to date that if they get through that whole laundry list, they will be drawing more carbon down than they are emitting with tractors, with hydraulic presses to press the wool, with the travel time of the different wool graders and shearers, the emissions associated with their travel. You can take all of the emissions associated with wool production and not only offset them with carbon farming on your ranch or farm, but you can do more than that. You can offset beyond just the cost of producing the wool, but you can do more. And that has societal benefit that people will pay for. And so we worked with the Union of Concerned Scientists to show how a wool base layer made through a typical global supply chain, including New Zealand wool and Chinese manufacturing, we compared that supply chain from a carbon perspective to what if we had decentralized regional wool scouring, wool spinning, knitting, and weaving in communities. Let's just even say the Western US had its own supply chain hub, and we could clothe our communities with what we grow and we manufacture it. We compared how that would affect the climate. So a typical wool base layer using the global supply chain, as described just a moment ago, would emit 33 kilograms of carbon into the atmosphere. On the far left, you see that bar. When we tweak the global supply chain, and we get to bar number 2 or 3, we add a little renewable energy to the Chinese manufacturing system. So you can see there's reductions. When we start to implement carbon farming on ranches and farms, we start to see very nice impacts. So the soil and carbon farming make a more significant impact in this modeling system than the renewable energy. So then we go all the way through. These are more impacts to soil in items number 5 and 6, or bar number 5 and 6. As we get to bar number 7, we are looking at carbon farming accentuated, good general land management. And then we also see that we've reduced the transportation distances, the commuter miles of those working in the mills. We have done everything we can across the supply chain. And I should add, this LCA, or life cycle assessment, includes the use phase. So we're including in these metrics when someone gets the base layer, how are they washing it? Cold water and air drying, regional supply chains, good carbon farming practices equate to bar number 7, which is that 37.3 kilograms of carbon for the entire supply chain, the entire use phase. We've drawn that much carbon out of the atmosphere. We call that a net negative garment, a garment that's contributed to the amelioration of climate change rather than the aggravation of climate change. We know that we can do this work, and so we continue to be very clear that brands that work with the climate beneficial wool pool, we say this is great. This is the first step. Keep buying American wool. Keep buying wool from growers who are doing these practices annually. Keep helping them get through their laundry list by incentivizing them to do so. But we need you to participate in the reinvestment of American manufacturing. That has to come hand in hand with carbon farming. You need both. So we, as advocates of American manufacturing, we are starting to do far more work on the development of fund development, new financial instruments to support low margin businesses like wool stations. It's critical that we continue to do this work. So the more growers, the more ranchers that take on carbon farming and rally to accentuate the power and the decentralization of textile manufacturing. We do need, every mill owner I speak to says, no, don't build a new mill. The fact of the matter is we do need to decentralize milling. We do need higher throughput, efficient, renewable energy powered milling systems. And we need more of them, and we need efficiencies within that. This is part of the journey. So the more growers who can advocate not only for themselves by doing carbon farming, but also be advocating for the manufacturing systems to come along, this is part of the overall picture. And this is what opens markets. This is what gets hearts and minds behind your product. And at this point, because people are so concerned, as they rightly should be, in fact, more concerned than they generally are, about the effects of climate change on weather and their children and grandchildren's future, and even their own future, because it's accelerating far faster than we anticipated. It is our responsibility to work together to tell our story. Agriculture should not be left out and demonized in the process of solving the climate crisis. Agriculture is a partner in this work, and not a partner that should be regulated, but a partner that should be incentivized. So I think if we do this work voluntarily together, we have a very good chance of improving the economic viability of our work while reestablishing American manufacturing and getting more wool on people's skin. All right, I think I have said enough. Thank you for the time. And again, sorry I can't be there in person. I hope you have a wonderful rest of your conference. All right, take care, everyone. Bye-bye.